Hi guys, welcome to this page of the notes, and again what we're doing is we're talking about three specific types of parallelograms. We're looking at rectangles, rhombuses, and squares. On the previous page we already took a look at rectangles and found the additional property was that all four angles are 90 degrees. Now what we're going to do is look at a second type of parallelogram known as a rhombus, and what other additional characteristics apply to rhombuses. So first, a rhombus is going to be a quadrilateral. It is a four-sided figure where all four sides are congruent. Now this is interesting. A rectangle was a quadrilateral where all four angles were congruent. All four angles were 90 degrees. Now we're looking at rhombuses where all four sides are congruent. That does not mean that all four angles are congruent. It absolutely does not mean that. We're now talking about the sides. So rectangles, all four angles are congruent. They're all 90 degrees. In a rhombus, all four sides are congruent. Now, what does that mean? Well, here we go. All of the properties about parallelograms still apply. So if a quadrilateral is a rhombus, then it is a parallelogram. Every rhombus is a parallelogram. What does that mean? Well, just like with rectangles, opposite sides are congruent. Opposite sides are parallel and congruent, which we already knew. We knew that in a rhombus, actually not only are opposite sides parallel and congruent, but all of the sides are congruent. That's what makes it a rhombus. In addition to that though, right, in a parallelogram, opposite angles have to be congruent. So opposite angles are congruent, right? Why? Well, because in a parallelogram, opposite angles are congruent. And a rhombus is a parallelogram. So I know opposite angles have to still be congruent. Also, I know diagonals bisect each other. Right, diagonals, but why? Well, in a parallelogram, the diagonals bisect one another, and a rhombus is a parallelogram. So what are the additional, in addition to these properties, because it's a parallelogram, what else do I know about a rhombus? Well, I know that a rhombus has four congruent sides, but actually, there's even more than that. Check this out. In a rhombus, if a parallelogram is a rhombus, then its diagonals are perpendicular. This is a really neat property about just rhombuses, right? If it's a rhombus, I know that those diagonals are going to be 90 degrees. They're perpendicular lines, right? Those diagonals are going to be, that's an additional property about rhombuses. So a rhombus has four congruent sides, and the diagonals are perpendicular to one another. Actually, it goes even a little bit further than that. Oh, sorry, let me get yellow here. If a parallelogram is a rhombus, each of the diagonals will bisect an opposite angle. This is a fantastic property. What it means is that each of these diagonals bisects the opposite pair of angles, right? Remember, bisect simply means it splits in half. So whatever angle J is, this angle up here, J, that diagonal splits angle J into two equal parts, right? Same thing over here. This is angle M, that diagonal splits M into two equal parts. So in addition to these three properties, because it's a parallelogram, we also have these additional properties because it's a rhombus. All four sides are congruent, right? The diagonals are perpendicular. They're 90 degrees to one another, and the diagonals will bisect opposite angles. Here we go. Let's do some problems, some example problems with those properties. Here we go. Okay, so I tell you that this figure is a rhombus. I want you to find the missing links or values in this figure. First, let's start off by finding what is xy. I want to know what is the length of this side right here. Well, I tell you it's a rhombus, which you then know all of the sides are congruent. So congruent, 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 congruent. That means if I can find the length of one of the sides, I know the length of all of the sides. Fortunately, I tell you that 6m minus 12 and 4m plus 4, those have to be congruent. They have to be. So that allows us to set up an algebra problem where I set those two sides equal to each other. We'll solve for m, and once I know one length of a side, I'll know all of them. So 6m minus 4m is equal to 4 plus 12. 2m is equal to what? 16. M is equal to 8. All right, let's go ahead and find the length of one of the sides. We'll do VW. 6m minus 12. So that gives me 6 times 8 minus 12. Again, don't fat finger something on your calculator, and I get 36. That's VW. But again, I want side xy, but I know all of the, it's a rhombus. I know all of the sides are congruent. Therefore, side xy is also 36. Let's keep going. I want you to find angle YVW. Let's find that angle. Angle YVW. So YVW. I want you to find that angle right in there. That angle right, YVW. That angle right in there. Okay, well, let's see what I know. Oh, interesting. Look at this. I know because it's a rhombus, I know that my diagonals are perpendicular to each other. What that means is that the diagonals form a 90-degree angle. And I tell you that this angle is 3n squared minus 0.75. But that has to be equal to 90 degrees because the diagonals are perpendicular. So that lets me set up an algebra problem where 3n squared minus 0.75 has to be equal to 90. Why? It's a rhombus, and the diagonals are perpendicular to each other. I know that has to be 90 degrees because it's a rhombus. So we solve for n. 3n squared equals, add 0.75 to the other side, so 90.75. Divide both sides by 3, n squared is going to be equal to 30.25. I need to get the n by itself, so we'll take the square root of both sides. And that means that n is equal to 5.5. n is equal to 5.5. Okay, great. Well, now that I know what n is, let's just plug it in, right? I can plug in an n right there. So that is angle WVZ, right? Angle WVZ, just that guy right there. WVZ is 9n plus 4. So angle WVZ is 9n plus 4. We'll go ahead and drop a 5.5 in there. So 9 times 5.5 plus 4. Don't fat finger something on your calculator. 53.5 degrees, angle WVZ. Now this is interesting, right? Remember, yet again, I know just this little part right here, right? Just that angle right there is 53.5. But that's not what I asked you for. I asked you for the angle in green. Again, a property of rhombuses, the diagonals bisect opposite angles. That means that this diagonal splits angle V in half. So if this part is 53.5 then this part is 53.5. All you have to do to find the angle I want is multiply by 2. So, angle YVW is equal to 53.5 multiplied by 2. Don't fat finger something on your calculator, and you wind up with 107 degrees. All right, so once again, using those properties of rhombuses to go ahead and solve some problems, right? Take as much time as you need to. Flashcards will certainly help you to memorize these properties of parallelograms, rectangles, and rhombuses. I know it's a lot of information to keep straight, right? So use whatever sort of memory tricks you need to use to help you remember those properties, but you absolutely need to know those properties to help you solve these problems. I got one more problem for you here. It's not really a problem, it's more of a question just to sort of help us hash out the similarities and differences between parallelograms and rhombuses. Here we go. What property about the diagonals of a rhombus is the same as the property of a parallelogram? Well, we know that both parallelograms and rhombuses, what's the same? We know that the diagonals bisect one another. That's whether it's a rhombus or a parallelogram, the diagonals must bisect one another. That's the same. Whether rhombus or parallelogram, diagonals bisect each other. But what's different? What special properties are unique to the diagonals of a rhombus that other parallelograms don't have? So what's different? Well, here's what's different. First, the diagonals are perpendicular. And next, right, so not only the diagonals of a rhombus are perpendicular, but the diagonals of a rhombus bisect opposite angles. Right, and that's really important information, right? When I give you a diagram and I tell you that that diagram is a rhombus, more than likely, I'm going to ask you about questions about these special properties. And I'm not going to come right out and say, what do you know about the diagonals of a rhombus? I'm going to do you know these properties, and can you use these properties to set up an algebra problem that you can then solve? Just like we did in this example problem right here. I needed to know that that diagonal bisects opposite angles in order to solve this guy, right? So, do you know the properties, and can you use those properties to solve for unknown lengths and angle measures? All right. What we'll do on the next page of the notes is take a look at squares and special properties dealing with squares. I'll meet you guys on the next page.